Assalamu alaikum everyone. I hope you people are fine at home and you are studying. I hope the previous lectures are clear. So today our lecture is about linearly independent sets. So the definition of linear independent sets is an indexed set of vectors v1, v2, v3 up till vn in V is said to be linearly independent if the vector equation c1v1 plus c2v2 plus c3v3 plus so on plus cnvn equal to 0, we call this equation as equation 1, has only the trivial solution. So what is the meaning of trivial solution? It means the values of c1, c2, c3 up till cn all should be equal to 0. So if I will solve this system of homogeneous linear equation and the values I will get as c1, c2, c3 up till cn are 0, so then it is linearly independent, and the set v1, v2 up till vn is said to be linearly dependent if 1, it means this equation, has a non-trivial solution. Now what does non-trivial solution mean? So non-trivial solution mean in this case, because we have a homogeneous system, you can see on the right side b is 0, so in this case we will get otherwise infinite many solution, because either we will get a trivial solution, it means all the values of c1, c2, c3 are 0, or we will get infinite many solution. So if we get infinite many solution, then it will be linearly dependent, and if we get all the values c1, c2 and cn 0, so then it will be linearly independent. So I think the definition is clear. So the vectors will be given, different type of vector v1, v2, v3, and they will be given. So we will apply this definition, and then we will find the values of c1, c2 up till cn, whatever required, and if all the values they are 0, so then it is linearly independent. If values are not 0, other than 0, then it is linearly dependent. So very simple. Now we can solve the example. So first example is determine whether or not the vectors 1 minus 2 1, 2 1 minus 1, 7 minus 4 1 are linearly dependent. Now there are three vectors given. Say you can call this vector as v1, this vector as v2, and this vector as v3. We give name v1, v2, v3. You can give any other name, u, v, w, or any other name. And then according to the definition, since here if we apply the definition, because there are only three vectors given, so the definition will be c1 v1 plus c2 v2 plus c3 v3 equal to 0. Because only three vectors were given. If four vectors given, then we can add one more. If only two vectors given, then you can stop here. So c1, and this is your v1 plus c2, then this vector is v2 plus c3, and this vector is v3 equal to 0. Now because this vector belong to R3, so we must write 0 also of R3. If it belongs to R2, it means only two number here given, just like only 1 minus 2, then we write here 0 0. So it depends. So 0, if we are talking about the matrices, then we will write accordingly the matrix. If we are talking about the polynomial, then we will write 0 polynomial. If it is like R2, R3 vectors, then accordingly we write here 0. So that should we have to be careful about that. And now c1 can be multiplied inside, c1 multiply 1, so it will be c1 multiply with minus 2, it is minus 2 c1 multiply with 1, so it is c1. Similarly, we can multiply with c2, it will be 2c2, and then minus c2. Plus, then you can multiply with c3 here, so 7c3 minus 4c3 and c3 equal to 0 0 0. Now you can see this three vectors we can add now. So we will add first component with first, so it means c1 plus 2c2 plus 7c3, then second component with second, and similarly third component with all third. So if I add like this, So it means C1 plus 2C2 plus 7C3. We added first component and then comma, and then the second component minus 2C1 plus C2 and then minus 4C3. Similarly, we added the third component C1 minus C2 and plus C3 equal to 0, 0, 0. Now both sides are equal, so it means here also three values. So first, second, third, here also 3. So it means first, if I compare both, so C1 plus 2C2 plus 7C3 equal to 0. Similarly, second minus 2C1 plus C2 minus 4C3 equal to 0. Similarly, C1 minus C2 plus C3 equal to 0. Now you can see this become homogeneous system of linear equation. Because why homogeneous? Here you can see all values are 0. And you already know from the previous lecture, whenever you solve homogeneous system of linear equation, there are two possibilities. Either you will get a trivial solution or you will get infinite many solution. So you already know the method how to solve this. So I will solve. So I will write the augmented matrix, you know, AB augmented matrix. So here augmented matrix will be, so it will be 1, 2, 7, minus 2, 1, minus 4, then 1, minus 1, 1. And your B values are all 0, so we write all 0. Now you want to solve by row reduction method. So what you can do, you can make all these three same. So here you can multiply row 1 with 2 and row 3 with also 2. So then it all will become 2, 2, 2. So if you multiply row 1 with 2, it will be 2, 4, then multiply 7 with 2, 14, and then 0. And this row 2 will remain same. Row 3 if you multiply with 2, so 2, minus 2, 2 and 0. And then you know, you can add row 2 plus row 1 and row 3 minus row 1. If you do this, so you will get 0, 5, 10, 0, 0, minus 6, minus 12, 0. And now you have to make below this 0, so you can multiply row 2 with 6 and row 3 with 5. So it will become 30, 60, 0, minus 30, minus 60, 0. Again you can add row 3 with row 2. So this will be all 0, 0, 0. Now you can see one whole row is 0. We can directly see here. So we will get infinite many solution. But still, even you can stop here and then you can directly write after this, because we will get infinite many solution. So therefore vectors are linearly dependent. But if you want to check whether it is dependent or not, you can just proceed. Let us see. So if, for example, I write this in equation form, so this will be 2C1 plus 4C2 plus 14C3 equal to 0. The next is 30C2 plus 60C3 equal to 0. Now you can see here, I cannot find the values of C1, C2. So if I find the value of here, C30C2 equal to, this will go other side, so this will be minus 60C3. So if I divide 30 on both sides, so it will be C2 equal to minus 2C3. It means, you can see the C2 will depend on C3. So that is why we are saying this linearly dependent, because C2 will depend on C3. And if I put value of C2 here, and so then C1 will depend on C3 and so on. So that is why these vectors are called linearly dependent. Okay, I think it is clear. I said after this step, you can directly write this. Because you can write, therefore system has a non-zero solution. Non-zero solution mean it can have infinite many solution, because here you will not get a unique solution like some number 2, 3, 4. Either you will get 0, 0, 0 or you will get infinite many solution. So that is why you can even write system has a non-zero solution. So therefore vectors are linearly dependent. Okay, we can you can solve one more example. Determine whether 1, 2, minus 3, 1, minus 3, 2, 2, minus 1, 5 are linearly dependent. So this is your homework. This you have to solve yourself. Now here I have written after solving. It means when you will apply the same process mean you apply the same definition, C1 V1, C2 V3, you solve this all like this, and then you will end up with similar system like this. Then you will solve this. After solving this, you will have a system of linear equation like this, and then after solving we will get the values of C1 0, C2 0, C3 0. Then the vectors are linearly independent. So this is your homework, but I have written here answer, so you can check yourself. It's very simple. Now next example is let V be the vector space of 2 by 2 matrices over R, real number. Determine whether the matrices A, B, C belongs to V are dependent, where A is given this matrix 1 1 1 1, B is 1 0 0 1, and C is 1 1 0 0. Now you have to check whether A, B, C are linearly dependent or not. So again, now our vectors, instead of V1, V2, V3, it is given as A, B, C. So again you will apply the same definition, C1 V1 plus C2 V2 plus C3 V3 equal to 0. But here as I said, V1 your A, V2 is B, and V3 is your C. So you can write C1A plus C2B plus C3C equal to 0. Then you can put the value of A here, C1A plus C2B plus C3C equal to 0. Now here you can see this all is 2 by 2 matrix, so you will write 2 by 2 0. So that I was explaining before. In the previous example, if you remember, we have written here 0 like this, because here all values were vector v1 v2 v3 that belongs to R3. So that is why we write here all 0 0 like that. And now your vectors belong to 2 by 2 matrices, so that is why we are writing here this 0 0 0 0 vector. So again you multiply C1 inside with each, so C1 multiply 1, so it will be C1 C1 C1, and then you can multiply C2 inside, so this will be C2 0 C2, plus you can multiply C3 inside, so this will be C3 C3 0 0, and then you know how to add matrices, so you can add first component with all, so C1 plus C2 plus C3. Similarly you can add the second one, C1 plus 0 plus C3, then you can add C1 plus 0 plus 0, and then C1 plus C2 plus 0 equal to 0. Now this is 2 by 2 matrix, this is 2 by 2 matrix, so they are equal, so their corresponding element must be equal to same. So therefore C1 plus C2 plus C3 equal to 0, C1 plus C3 equal to 0, C1 equal to 0, and C1 plus C2 equal to 0. Now from here, now after this, actually if for example that is not solvable, then you will do like the previous example. But here we are lucky, already value of C1 is given, which is 0. So I can substitute here value in C1 value here, I can get the value of C2, and then I can put value of C2 and C3 here, I can get I can put the value of C1 C2 here, I can get the value of C3. So here no need to make a system of linear equation and then augmented matrix and all this, no need, because here you can see already the values of C1 is given. So the value of C1 is 0. So from 3 I can get the value of C1 0. From 4 I can put value of C1 0, and then I can get the value of C2 0. From 2 I can put value of C1 0, I can get the value of C3 also 0. And from 1, because we already find the value of C1 C2 C, so there is no need to do anything. Just if you want to recheck your answer, if you put values of C1 C2 C3 here, so it definitely it will be 0 equal to 0. But no need to do this step, because you already find the values of C1 C2 C3. So therefore the values of C1 is 0, the value is C2 is 0, and the value of C3 is 0. So therefore the matrices A, B, C are linearly independent. Okay, now I think that example is also clear. So again one question for homework, again you have to check whether the matrices A, B, C are dependent or not. So A is given this, B is given this, C is this. So you can check this. I think if you will solve this, so it will be linearly dependent. The answer here will come linearly dependent. You can check, you can, this is your homework. Okay, next example is, let V be a vector space of a polynomials of degree 3 over R. So determine whether U, V, W are linearly dependent or not. Now first example we did for vectors in R power 3, second we did for matrices, and now we are doing for polynomial. So and polynomial of degree 3. In exam we can ask question of polynomial of degree 2 or even polynomial of degree 4 or any question like this, but the method will remain same. So here again we apply the same definition, since C1U plus C2V plus C3W, because here U, V, W 3 vectors are given. So we will write C1U plus C2V plus C3W equal to 0. Again you can put the value of C1U plus C2V plus C3W equal to 0. Now 0 here will be your zero polynomial of degree 3. So we will write here 0 because here degree 3 maximum power 3. So 0 t3 plus 0 t square plus 0 t plus 0. You can see this is 0, but polynomial 0 polynomial of degree 3. So now you can multiply this c1 inside. So c1, it will be c1 t cube minus 3c1 t square plus 5c1 t plus c1. Similarly, you can multiply c2 inside. So this will be c2 t cube minus c2 t square plus 8c2 t and plus 2c2. And similarly, you can multiply this c3 inside. So this will be 2c3 t cube plus 4c3 t square plus 9c3t and plus 5c3 equal to this 0 polynomial. So then what you can do now here, now if you see here, this here c1 t cube, here is also c2 t cube, here is also 2c3 t cube. So what I can do, I can take t cube common from all this. So if I take t cube common, mushtarak, so then what is left here c1, what is left here c2, and what is left here 2c3. So it means this will be c1 plus c2 plus 2c3 because t cube I have taken common. Similarly, I can take t square common. So if I take t square common, so you can see here t square, you can see here t square, you can see here t square. So if I take t square common, so then it will be minus 3c1 minus c2 and plus 4c3. And similarly, if I take t common, because here is also t, here is also t, here is also t. So if I take t common, so then it will be 5c1 plus 8c2 plus 9c3 and t, and plus without any t, it means this is c1 and then plus 2c2 and then plus 5c3 equal to this 0 polynomial. Now you can see why have we written this 0 polynomial, because now you can compare the coefficient. Now here these two sides, they both are equal. So what is coefficient of t cube here? It is 0. What is coefficient of t cube here? Is this. So it means I can write, if I compare the coefficient of t cube, t square, t and constant, so it will be equal to, if I compare coefficient of t cube, it will be equal to c1 plus c2 plus 2c3 equal to 0. This. And similarly, if I compare coefficient of t square, so this will be minus 3c1 minus c2 plus 4c3 equal to 0. Similarly, if I compare coefficient of t, so this will be 5c1 plus 8c2 plus 9c3 equal to 0. And similarly, if I compare the constant, so this will be c1 plus 2c2 plus 5c3 equal to 0. This. Now you know very well how to solve this system of linear equation, homogeneous system of linear equation. Again, you can write the augmented matrix. So you know how to write this augmented matrix, and now you want to make this all same so that you can make this 0. So this I think you can do yourself. I will not spend more time here because we have done many times now this, but I have done here all the calculation for you, so you can check this. So we will get here 0, and now we want to make all these three same. So because these were a little bigger number, so what I did, to make these numbers small, so I divided this first with 10, I divided the second one with 3, I divided the third one with 15, so that now you can see this minus 2, 3, 1, very small number come. Otherwise you can go with the same number, but your number will be larger. So I think if possible, and you can see here no fraction is coming, so it's good if we have small number. Now you can see minus 2, 3, 1, so it is easy to make row reduction. So I can multiply this row with 3 and this with 2 and this with 6, so I will get minus 6, 6, and similarly all other, and then I can make this below 0. And now you can see here after this, even you can make this 0, there is no problem, but no need to solve this, because you can see here minus 5c3 equal to 0, 15c3 equal to 0. It means minus 5c3 equal to 0, 15c3 equal to 0. And this first is 15c1 plus 15c2 plus 30c3 equal to 0. Then second minus 6c2 minus 3c3 equal to 0. So and minus 5c3 equal to 0, and this 15c3 equal to 0. So it means minus 5 cannot be equal to 0. So c3 will be equal to 0, or 15 cannot be equal to 0, c3 equal to 0. So we get the value of c3 0 from 2. If I put the value of c3 here 0, I can get the value of c2 also 0. and then from 1 I can put the value C2 and C3. I will also get the value of C10. So therefore C10, C20, C30, it means U, V and W are linearly independent. So now question for homework is a similar question. Now this you have to show that the polynomials U, V and W are linearly dependent, okay, where U is given as this, V is given as this, W is this. So it means now here you will not get values of C1, C2, C30, but in this case you will get infinite many solution. So I hope lecture is clear. So please try to solve these questions at home, and if you have any question, any problem, so during online Moodle session, so we can discuss inshallah in next class. So please try to solve all these questions, and take care of yourself and your family, and have a good time. Assalamu alaikum.